Hello again, Audrey. So we met again. Now we are going to discuss about the question number 3 in your exercise 4. Okay, I'm going to quote this here. Okay, and after that, before actually doing the questions, let's do some background information or theory on how to work on this type of questions. Okay, now the question is why double dash x here, y double dash x equals 3yx, 3y dash, okay, minus 2y. I'm not writing the function of x because it's supposed to be clear from the question itself. 3 double dash x is equal to 3y dash minus 2y. And we also have the boundary condition. Y0 is 1 and y dash of 0 is 2. Okay. Now, before we go further, let's try to arrange this equation into the standard form. The standard form says that anything that contains y, you put them on the left-hand side. Anything that is purely on x, put them on the right-hand side. Okay. With the highest derivative, we'll be having the positive coefficient. So we are going to arrange this into y double dash minus 3y dash plus 2y equals 0. Okay, this is what we call a homogeneous equation. Homogeneous means it only has a single mix between the y dash and any derivatives. Okay, so there is no purely independent variable. No terms contain only x. Homogeneous variable, right-hand side on the standard form is 0. Okay. Now, in this case here, all of them are linear because none of them is going to be multiplication or raised to any number. It's linear because all of the y's here, all of the y, they are not going to be multiplied. They're not going to be, they're not raised to any power. So that's we call them linear here. This, and this. Okay, y an derivative is not raised, squared, or cubed, or anything. Okay, now, beside this, see that the coefficient, the number in front of the y or their derivatives are all numbers, non-variable, constant. So this is what we call a constant coefficient. The number in front of them, in front of the y, the dependent variable, are all constant, not variables. No x, okay, in front of y are derivatives. Okay, so this is, we have differential equation, order 2, homogeneous, okay, linear, and also constant coefficient. Those are the requirements in exercise 4. Okay. Now, enough with that. How do we solve this type of equation? Okay, before we go further here, let's take the case of differentiating constant, differentiating general terms in Y. If you have Y is A times e to the power of kx, k being a constant, then y dash is going to be k times a e to the power of kx, y dash is going to be k squared a e power kx, etc. So y triple dash is going to be k cube a e to the power of kx. This is the general form of the equation here. If y is in this form, you can say that y to the nth, the derivative to the nth power is going to be k power n a times e to the power of kx, which is the original variable. Okay, now let's say we have a general equation, okay, general equation of higher variable. Let's say we have a number n an f dash n, not dash, let's call them y yn plus a n minus 1 y n minus 1 plus a n minus 2 y n minus 2, etc. Until the end, you have y plus a 0, y equals to 0. This type of equation will have the general formula of this. This is the general formula for this type of equations. A times e to the power of kx. Now, if we substitute all of the number here to any power, we're going to have this form. A n times k power n times a e power kx plus a number n minus 1 k to the power of n minus 1. I mean this two. Yeah. K power n a e k power kx plus a n minus 2 k to the power of n minus 2 a e power kx, etc., etc., until we have a1 k power 1 a e kx a e power kx, my bad, and the last one plus a0, okay, no longer any k, a times e to the power of kx. equals to 0. Okay. Now, we know that the factor, we can factorize this. Everything has this same common factor. A times e to the power of kx. If we multiply this, we're going to have kn, we should have an first. An k power n plus a n minus 1 k power n minus 1 plus a n minus 2 k power n minus 2 etc. plus k plus a0. a1 k1 plus a0 equals to 0. Sorry, going this way. Now, this will be never 0. Guaranteed. E to any factor, e to the raised to any power will not be 0. Close to 0, yes, possible, but never exactly 0. Hence, it is this one that will be 0. This part of equation here, the one that can be 0. So if we want to solve this equation, means we need to solve the one in the bracket. We call this characteristic equation. Characteristic equation. This equation is the character or the specialty or the uniqueness of the differential equation. Solve this and you will going to solve the original equation. Now, we know from the discussion of polynomials, if we have polynomial to n power, guaranteed it will have n number of root. So if you have in polynomial, if you have a and k power n plus a n minus 1, k n minus 1 plus a n minus 2, k power n minus 2, etc. until plus a 1, k power 1 plus a0 equals 0. This is guaranteed to have number of roots is going to be n. But what will be the value of each number? We can have several cases. Okay. It is possible to have the roots here to be either real or imaginary. If they are imaginary, they will always comes in conjugate pair. Okay, now if there are for any real roots, then the number is going to be easy. If it is real root, real number of k, then the answer is going to be y is a e to the power of kx. That's it. That's the value that we are looking for. But if it is a real number, it is possible to have repeated roots. If there is a repeated roots here, then we're going to have, for each repetition, one more factors multiplied by x. Okay. If it's repeated here, then the first answer is going to be a e to the power of kx. Then another one here is going to be a times x, okay, e to the power of kx. This is the second root, second repeat. If it is a third repeat, then the y is going to be a x squared e to the power of kx. That's the third repeat, etc. Okay, so if you have a real number, go back to the original question. The answer will be y is a times e to the power of that value of k here. The k is going to be a real number. If they are repeated roots, this is the first root then. This is the first root. The second repeat, third repeat, etc. We're going to multiply this with the factor of x. X to the power of 1 for the second repeat, x to the power of 2 for the third repeat, etc. The main part, e to the power of kx times a, still the same. So this is the first case here. We have real number. And then we have real number but repeated roots. How about imaginary number? We know that imaginary number here, they will always come in pairs. Now, actually, it is still possible, in this case here, to find the value of k here. We have them here, a. Now, k is going to be imaginary number. I'm going to write it as r cis theta. Okay, now in this case here, they'll always be in the form of r cis theta. If it is r cis theta, they come in pair, right? So we are going, it is possible for us to write them in the form of y is a times e to the power of, I'm going to write this as k as p plus qi. P plus qi times x. So x multiplied by a real number and imaginary number here. But they always comes as plus or minus. So y1 and 2. y1 and 2. 1 is usually the p plus q times I, and the number 2 is e times p minus qi. Now, in this case, e to the power of p plus q, we can write this in the equivalent value in the form of polar. It's easier. rather than write them as e to the power of ep plus qi, we can write them as e to the power of px, okay, plus e to the power of qi of x. Now this together, we can write them as the form of, okay, it's going to be r, okay, cos theta plus I sin theta. This is easier for us to write it at this form. Okay. It's going to be r cos and sin theta. So we're going to have them here in the form of a r cos theta plus r sin theta x. Okay. In this case here, the I takes out because we are going to put them here. Rather than y is no longer an I here, it's supposed to be cheese, right? Cos plus I sin. Okay. The reason is if we have E plus P plus QI and E plus P minus QI, and we divide them by the I here, we get the sin theta. So to short it, okay, if we can find it in the form of imaginary number, okay, in the form of r cheese theta, we get them into trigonometric couple. A times r cos theta x and A times r sin theta x. No longer getting the I because the I is used in changing it from the e to the power of complex number into two trigonometric function. This is the general answer for this type of question. Let's start with each case example in the next several questions. We're going to see question number 1, case of real number for k. So back to our original question. In question number 3, we have y double dash equals 3y dash minus 2y, which change into y double dash minus 3y dash plus 2y equals 0. Check the characteristic equation. Characteristic equation in this case, we simply see the coefficient. So it's going to be k squared minus 3k plus 2 equals to 0. This is our characteristic equation. To find the root, we can do any of the way, but I think this one simplest if we just factorize. This is real roots and distinct. Hence, the answers are a e to the power of 2x and e to the power of x. The number and number 2 refers to the number of roots. A number 1 and number 2. If there are some other roots, we're going to have a number 2, etc., etc., etc. Okay, so here we have the answer is going to be a1 e to the power of 2x and a2 e to the power of 1x or just x. Now, how to find the constant a1 and a2? Well, in this case, we are going to substitute with the known information. This is y. From this, we know that y dash is going to be 2a1 e power 2x plus a2 times e to the power of x. This value, these functions, we can substitute the known value. We know that y0 is 1 and y dash of 0 is 2. Okay, if y0 is 1, it follows that 1 equals a1 times e to the power of 0 plus a2 times e to the power of 0. Okay, so 1 is a1 plus a2. Y dash 0 is 2. So 2 is 2a1 times e to the power of 0 plus a2 times e to the power of 0. Again, e to the power of 0 is 1. We can ignore, and we have them 2 is 2a1 plus a2. Any way to find a1 and a2 is acceptable. We are going to have system of variables. In this case, okay, you can use any formula such as, this is going to be the simultaneous equation of several variables, okay, a1, a2, etc. Okay. I think this is very simple. If we just subtract him, we know -1 is negative a1, hence a1 is 1. Okay. And if we substitute it, we get a2 is going to be 0. Put this into the y. Y is a1 e to the power of 2x plus a2 e to the power of x. If we put a1 is 0, a1 is 1 and a2 is 0, 1, that's going to be e to the power of 2x plus 0 times e to the power of x. This is none. So the final answer is just this, e to the power of 2x. That's the final answer. So y is e to the power of 2x. This is the case of the characteristic equation with real coefficients. I mean with real coefficients, and in this case, it's actually whole numbers, so it's very easy. Next question, we're going to see still real number, but it's going to be rational. That's a bit for today. Thank you.